Welcome to our poster, Contextual Density Ratio for Language Model Biasing of Sequence-to-Sequence ASR Systems. This is a work that we have developed at Nuance, and I hope you enjoy the content. In this work, we improved the recognition accuracy of name entities within end-to-end systems. These systems have been greatly adopted by the literature and the industry, but they complicate the integration with external language models, and these language models are extremely helpful for recognizing single-door or infrequent words and phrases, many of which are name entities such as contact list names or song names. Obviously, the training data is never going to be representative of the particular name entity distribution that we will see in deployment. In general, several techniques have been proposed to exploit external language models such as shallow fusion and density ratio, among many others. But recently, contextual shallow fusion was proposed to bias the search of name entities by using begin entity and entity tags. In this work, we extend the contextual shallow fusion by applying density ratio to subtract the internal language model component of the end-to-end systems when biasing a name entity distribution. We call this method contextual density ratio. During training, we find the name entities such as method in this example, and then we enclose them within name entity tags so that the system can learn to recognize the name entities. At inference, the system proposes several tokens which include the name entity tags that we use to identify when we are within tags, and in that case we apply 3 scores instead of the standard end-to-end score. This end-to-end score has some internal language model distribution that we balance off by using this internal language model estimation, and then we add on top of that the shallow fusion distribution to bias the name entity distribution. For each beam search trace, we have clearly 2 regions, the outside tags region, where we only apply the end-to-end score, and the within tags region, where we apply the 3 score we have previously discussed, the end-to-end, the name entity language model biasing, and the internal language model estimation to bias the end-to-end distribution. We apply the proposed techniques to an internal task where we wanted to improve the name accuracy recognition. All the systems that we built in this task obtain a very similar error rate within noise range, and the baseline obtains a 44.1 error rate within the name tags that can get improved down to 13.3 if we use standard shallow fusion, and when extending that with contextual density ratio, we improve that down to 23.6. We have run more experiments. Please refer to the paper for those, and thank you very much for listening.